Have you ever wondered if our universe is the only one out there? A question that keeps scientists and philosophers alike awake at night. What if I told you that our universe might just be a tiny bubble in an infinite sea of other universes? This concept, known as the multiverse, suggests that there could be an infinite number of universes, each with its own physical laws and dimensions. Our universe is so vast and complex that it's hard to wrap our minds around it. It's packed with galaxies, stars, planets, and a whole lot of empty space. And yet, it may be just one of countless others. Just imagine, there could be a universe where dinosaurs never went extinct, or one where you're the president. The universe, or should we say the multiverse, is filled with profound mysteries waiting to be unveiled. So buckle up as we dive into the cosmic ocean to explore some of these enigmas. The universe holds many mysteries, some of which we'll explore today. The universe's vastness is difficult to comprehend. We often speak of the universe in terms of light years, a distance so immense, it's measured in the amount of time light travels in a year. But even that fails to capture the true scale of the cosmos. Imagine, if you will, a cosmic ocean filled not with water, but galaxies. There are over 2 trillion galaxies in the observable universe, each one a swirling mass of stars, dust, and dark matter. And these galaxies aren't just close neighbors. The distances between them are so vast, they can only be measured in millions and even billions of light years. Consider our closest galactic neighbor, the Andromeda Galaxy. It's located approximately 2.5 million light years away from us. Now, light travels at a speed of nearly 6 trillion miles in a year. Multiply that by 2.5 million, and you'll begin to grasp the staggering distance to Andromeda. And remember, that's just our closest neighbor. The galaxies in our universe are like tiny islands adrift in an unimaginably vast cosmic sea. Their isolation is so profound, their distances so immense, that the light we see from distant galaxies left their stars millions or even billions of years ago. We are, in essence, looking back in time every time we gaze into the night sky. The universe is so vast that it might as well be infinite for our human perspective. Did you know that the universe is constantly expanding? Yes, you heard that right. The universe, with its infinite galaxies, stars, and planets, is growing larger every single moment. But how did we come to know this? Well, it's all thanks to the Big Bang Theory. This theory, which is widely accepted by scientists around the globe, suggests that the universe began as an incredibly hot, dense point, roughly 13.8 billion years ago. Since that point, it's been expanding outward and cooling down. But how did scientists discover this expansion? It was Edwin Hubble, an American astronomer who first observed that distant galaxies are moving away from us. This observation led to the idea that the universe is expanding, and not just expanding but doing so at an accelerating rate. Now, you may wonder what this expansion means for us. Well, the implications are immense. As the universe expands, galaxies move further away from each other. This could mean that in the distant future, galaxies outside our own will be so far away that they will no longer be visible to us, changing our night sky forever. So not only is the universe vast, but it's also getting bigger every second. Yes, the cosmos is not just a static backdrop, but a dynamic, ever-changing entity, full of surprises and mysteries waiting to be unraveled. Contrary to what you might think, most of the universe isn't made up of stars and planets. In fact, the components that we can see and study, stars, galaxies, and interstellar gas, only make up about 5% of the universe. The rest of it, a whopping 95%, is made up of 2 elusive and mysterious entities, dark matter and dark energy. Let's start with dark matter. It's called dark because it doesn't emit, absorb, or reflect light, which makes it incredibly hard to detect. But we know it's there because of the gravitational effects it has on visible matter. You see, galaxies spin at such high speeds that they should tear themselves apart, but they don't. Something unseen is holding them together, and we believe that something is dark matter. Then there's dark energy, an even more mysterious substance. It's believed to be the reason why our universe is expanding at an accelerating rate. Unlike dark matter, which pulls things together, dark energy is pushing galaxies apart. It's like an invisible force field permeating all of space, working against gravity to drive the universe's expansion. The study of dark matter and dark energy is one of the greatest challenges in modern physics. Since we can't see or touch these substances, we have to rely on indirect methods to study them. We're like detectives, searching for clues in the cosmic phenomena we can observe. It's a daunting task, but it's also a thrilling one. Each discovery brings us one step closer to understanding the nature of our universe, and who knows what other surprises are waiting for us in the dark. So, the universe is largely made up of substances we can't see or fully understand. It's a humbling thought, isn't it? But it's also a reminder of how much there is left to explore and discover. The universe is full of mysteries, and we're just beginning to scratch the surface. Black holes, one of the most fascinating phenomena in the universe. These cosmic behemoths are areas in space where gravity is so strong that nothing, not even light, can escape their pull. But how do they form? Well, when a massive star burns out its nuclear fuel, it collapses under its own gravity. This collapse triggers a supernova, a stellar explosion so powerful it can briefly outshine an entire galaxy. The remnants of this supernova can then form a black hole. Now let's delve into some unique characteristics of black holes. They have an invisible boundary, known as the event horizon, beyond which nothing can return. And if you were to fall into a black hole, you'd experience something strange and rather unsettling: spaghettification. This is where gravity stretches you into a long, thin shape like a piece of spaghetti, hence the name. Black holes also have a profound effect on time. Close to a black hole, time slows down. This is due to a phenomenon called time dilation, a prediction of Einstein's theory of relativity. Black holes are more than just cosmic vacuum cleaners. They play a crucial role in the formation and evolution of galaxies. They challenge our understanding of physics and force us to question our perception of reality. Black holes are a perfect example of how bizarre and fascinating the universe can be. Today, we've taken a journey through the cosmos, uncovering some of its most fascinating secrets. We've marveled at the sheer vastness of the universe, a scale so enormous that it dwarfs our human comprehension. It's a realm that stretches out far beyond our solar system, beyond even the most distant galaxies that our telescopes can see. It's a size that humbles us, reminding us of our tiny place in the grand scheme of things. We've also explored the ongoing expansion of the universe, a process that has been underway for nearly 14 billion years. Just like a balloon being blown up, the universe keeps on growing. But unlike a balloon, there's no known limit to how big it can get. This expansion is a testament to the dynamic, ever-changing nature of the cosmos. We've delved into the enigmatic world of dark matter and dark energy, which together make up a staggering 95% of the universe. These invisible, intangible entities, though unseen and unfelt, exert a profound influence on the universe as we know it. They're the invisible puppet masters, pulling the strings of galaxies and shaping the very fabric of space-time. And who could forget our journey into the heart of the universe's most mysterious objects? Black holes. These cosmic beasts, born from the death throes of massive stars, are places where gravity is so strong that nothing, not even light, can escape their grasp. They're the universe's ultimate vanishing points, where matter goes in and never comes out. Yet they're also key to understanding the laws of physics at their most extreme. As we reflect on what we've learned, it's clear that the universe is not just a vast expanse of space. It's an ever-expanding, ever-evolving tapestry of cosmic phenomena, from the incredibly large to the incredibly small, from the brightly visible to the deeply hidden. It's a place where matter and energy dance to the rhythm of physical laws, weaving a cosmic ballet that's both stunningly beautiful and profoundly mysterious. The universe is a vast, expanding, and mysterious place, full of wonders we're only beginning to understand. The more we learn, the more questions we have. Isn't it fascinating?